During the fighting in Sicily in the summer of 1943, German forces captured American radio equipment that would force them to confront an uncomfortable truth. Among the seized items was a small olive drab box with a telescoping antenna that doubled as the power switch. It fit in one hand 5 miniature vacuum tubes, a single quartz crystal for frequency control. The entire unit weighed less than 5. German signals experts examined the captured equipment and compiled a formal evaluation. They described the American handheld radio as extremely effective. Its lightweight, small size, efficiency, and range made it ideal equipment for forward observers and companies. They had nothing like it. 7,000 mi away. Factory at 4545 West Augusta Boulevard in Chicago, a Polish refugee engine named was refining circuit designs for an even more advanced radio. This one was a backpack unit that used frequency modulation instead of amplitude modulation. It could cut through the static of tank engines and artillery explosions. It could reach 8 m over open terrain. American factories were producing them by the tens of thousands. The German experts examining that captured handheld radio did not yet fully understand what they were looking at. They were looking at the reason Germany would lose the war. The misjudgment began long before the first shot was fired. German military intelligence compiled reports on American industrial capacity and technological capabilities throughout the 1930s. The conclusions were remarkably consistent. America was a nation of businessmen and consumers, not engineers and warriors. Its factories made automobiles and refrigerators, not precision military equipment. Its people had grown comfortable during the long peace and lacked the technical discipline required for modern warfare. Himself shared this contempt for America. In January 1942, just weeks after Pearl Harbor, he told his inner circle that he did not see much future for the Americans. It was a decayed country, he said. They had their racial problem and the problem of social inequalities. How could one expect a state like that to hold together? His dismissiveness reflected a broader German failure to take American capabilities seriously. Hermann Göring, head of the and one of his closest confidants, dismissed American production claims as fantasy. When President Franklin announced in May 1940 that the United States would produce 50,000 aircraft per year, the German high command laughed. In 1939, American military aircraft production had been fewer than 3,000 planes total. The idea that this could increase by a factor of nearly 20 seemed absurd. German planners dismissed American claims of industrial potential as propaganda. When they examined American military equipment in the years before the war, they found it adequate but unremarkable. American tanks were thinly armored. American aircraft were competent but not exceptional. American artillery was conventional. Nothing suggested that America possessed any decisive technological advantage in the areas that Germans considered important. They were measuring the wrong things. They looked at tanks and aircraft and artillery, the visible symbols of military power. They did not look at the invisible infrastructure that made modern armies function. They did not understand that a radio small enough to fit in a soldier's hand could matter more than a tank regiment. The story of American radio superiority begins not on a battlefield but in a university laboratory. In 1930, a Columbia University professor named filed a patent application that would reshape military communications forever. The patent was granted on December 26, 1933. Was already one of the most celebrated inventors in America. During the First World War, while serving as a Signal Corps captain in Paris, he had invented the super receiver, the circuit design that would become the foundation of virtually every radio built for the next century. He had also invented the regenerative circuit and the super regenerative circuit. 3 of radio's 4 fundamental innovations came from his mind, but his 4th invention would prove the most consequential, called it frequency modulation, or FM. Instead of varying the amplitude of a radio wave to carry information, FM varied the frequency. The difference seemed technical and obscure. It was neither. Conventional AM radio worked by varying the strength of a radio signal. A stronger signal represented one part of a weaker signal represented another part. This approach was simple and well understood, but it had a fatal flaw. Any source of electrical interference, from lightning to engine ignition to nearby machinery, could affect the amplitude of a signal. The interference blended with the intended transmission, creating the static that plagued every AM broadcast. FM worked differently. Instead of varying amplitude, it varied the frequency itself. The receiver was designed to respond only to frequency changes, ignoring amplitude variations entirely. This meant that electrical interference which affected amplitude was simply filtered out. On November 6, 1935, stood before the Institute of Radio Engineers in New York and demonstrated what FM could do. He transmitted sounds that were unrecognizable on conventional AM radio. A glass of water being poured, paper being torn, the rustle of fabric, a piano playing with crystal clarity. The audience sat in stunned silence. They had never heard such fidelity from a radio transmission. FM eliminated the hiss and crackle that plagued every AM broadcast. It stripped away interference from electrical equipment, engine ignition systems, and atmospheric static. The demonstration marked the beginning of a revolution in radio technology. The implications for military communications were profound. A battlefield is the worst possible environment for radio. Tank engines generate massive electrical noise from their ignition systems. Artillery explosions create electromagnetic pulses. Aircraft engines crackle with interference. Weather conditions change constantly. AM radios in combat were plagued by static so severe that operators often could not understand transmissions. Messages had to be repeated multiple times. Critical information was lost in the noise. FM changed everything. Its limiter circuits stripped out amplitude-based noise. Its capture effect locked onto the strongest signal while suppressing interference. Its squelch circuits meant operators no longer had to listen to constant static between transmissions. Communications became clear and reliable even in the worst conditions imaginable. In 1938, Colonel Roger, director of the Signal Corps Laboratories at Fort New Jersey, made what himself called the most difficult decision of the history of radio which anyone was ever called upon to make. Colton directed that all future American military radios would use frequency modulation. The decision was controversial. FM required more complex circuitry than AM. It demanded precise manufacturing. It used wider bandwidth. Many engineers argued that the added complexity was not worth the benefits. Overruled them. He understood what FM meant for soldiers in combat, was so committed to the war effort that he offered free use of all his FM patents to the War Department for the duration of the conflict. America would go to war with the most advanced radio technology on Earth, and its inventor asked nothing in return. The German military made a different choice. They stayed with amplitude modulation. This decision reflected deeper differences in how the two nations approached electronics. Germany had excellent radio engineers. Companies like Laurin and produced sophisticated equipment. Their radios were well built and ruggedly constructed. German tubes were standardized for easy replacement in the field. The RV-12P2000 Universal became the standard receiver tube produced in enormous quantities. German military culture emphasized reliability through simplicity. They preferred proven technology over untested innovation. Had won stunning victories in Poland, France, and the early campaigns in Russia using AM radios. Blitzkrieg had conquered most of Europe. Divisions had sliced through enemy defenses with devastating speed. German communications, while not perfect, had been adequate to coordinate these operations. Why change what was working? But German success had obscured a critical weakness. Their early victories had been won against enemies who were surprised, unprepared, and often technologically inferior. The Poles had obsolete equipment and were overwhelmed. In weeks, the French were caught off balance by the speed of the German advance and collapsed before they could recover. The Soviets in 1941 were reeling from purges that had gutted their officer corps and were pushed back hundreds of miles in the first months of fighting. German communications had been adequate against these opponents. Was an annoyance, not a decisive handicap when fighting enemies who were already beaten. But the Germans had not yet faced an enemy who could match their tactical proficiency while possessing superior communications technology. They would soon discover what that meant. The American radio industry had grown up serving a vast civilian market. By the early 1940s, roughly 90% of American households owned a radio receiver. This massive market drove companies to compete on size, cost, and performance. Vacuum tubes became smaller as manufacturers sought to build portable receivers. Manufacturing became more efficient as volume production drove down costs. Engineers learned to pack more capability into less space because consumers wanted radios they could carry. When war came, this expertise translated directly into military Advantage: Germany had no equivalent market pressure. Their radio industry served a smaller civilian population and faced less competitive pressure too. German tubes were well engineered but sized for stationary or vehicle-mounted equipment. When German engineers designed military radios, they built them to military specifications. Using military methods, they did not have decades of consumer electronics experience teaching them how to make components smaller, lighter, and more reliable. The gap became visible in the first months of American combat operations. The contrast between expectation and reality would prove devastating for German strategic planning. In November 1942, American forces landed in North Africa as part of Operation Torch. It was the first major American ground combat of the war, and communications problems immediately revealed themselves. Artillery forward observers spotted enemy movements but could not reach gun lines in time because their radios failed under battlefield conditions. The static was overwhelming. Transmissions broke up. Messages had to be repeated endlessly. Infantry units lost contact with supporting armor. Coordination between ground forces and aircraft broke down repeatedly. The Army, it was later said, paid for many communications shortcomings in blood. The failures at Operation Torch would not be repeated. The solution was already in development back in Chicago. In 1940, a Connecticut engineer named Daniel Noble joined Manufacturing Corporation as Director of Research. Noble had previously designed the world's first statewide two-way FM radio system for the Connecticut State Police. He understood what FM could do in practical field conditions, not just laboratory demonstrations. When the Signal Corps issued a contract for a new portable AM radio, Noble objected strenuously. He told Colonel J.D. bluntly that he felt this was a grave mistake and that the area of development should be for an FM portable unit. Noble argued that AM was fundamentally unsuited for battlefield conditions. No amount of engineering could overcome the laws of physics. Only FM could deliver reliable communications in combat. Was convinced. The contract was redirected. Noble assembled a team of brilliant engineers at the factory on Augusta Boulevard in Chicago. His principal radio frequency designer was a Polish-born engineer who had graduated from Warsaw University of Technology in 1934, had come to America before the war to continue his education, and was still in the country when Germany invaded Poland in September 1939. He could not go home. His family was trapped behind enemy lines, facing the brutality of Nazi occupation. Channeled his anguish into work, he threw himself into the radio project with an intensity that impressed even his driven colleagues. Working 18-hour days in the Chicago factory, he refined circuit after circuit. The radios he helped design would contribute to the liberation of his homeland. Every technical problem he solved brought that liberation closer. The team also included Marion Bond and Bill. They worked long hours in conditions that would later be described as frantically intense. The war was going badly. In late 1941 and early 1942, American forces were being pushed back across the Pacific. German submarines were sinking ships faster than American shipyards could build them. Every day of delay in delivering better equipment meant more American soldiers dying with inadequate communications. By spring 1942, the team had two working prototypes of what would become the SCR-300. They first tested the radios in Chicago, transmitting between the Tropic Air Building roof and that Thatcher Woods Forest Preserve. The results exceeded every expectation. The specification called for 3 mi of range. The prototypes achieved 8 mi. The team then took the radios to Fort Kentucky for formal acceptance testing before Signal Corps and infantry board officers. These were hard-headed military professionals who had seen countless promising technologies fail under field conditions. They were skeptical of claims from civilian engineers. Demonstration drew what was described as an unusually enthusiastic response from the hard-headed infantry and Signal Corps officers who witnessed it. They understood immediately what this technology meant for soldiers in combat. The SCR-300 operated on FM at 40 to 48 m across 41 channels. It used 18 miniature vacuum tubes in a sophisticated double super receiver, the same circuit architecture that had invented in Paris during the First World War. A single tuning control adjusted both transmitter and receiver simultaneously, simplifying operation under the stress of combat. An automatic frequency control circuit ensured clear communication without precision tuning. compensating for the frequency drift that plagued less sophisticated radios. The entire unit weighed approximately 38 with the standard battery and delivered roughly 20 to 25 hours of battery life. A single soldier could carry it on his back and operate it while moving. This mobility was revolutionary. Previous infantry radios had required multiple operators and could only be used from fixed positions. The SCR-300 went where the soldier went. Nearly 50,000 SCR-300 radios were produced during the war. First units saw combat in the Pacific at New Georgia in August 1943. Colonel Francis reported it was exactly what is needed for communication in this theater. The dense jungle canopy that blocked conventional radio signals posed fewer problems for the FM sets. In Europe, the first units were airlifted for the invasion of southern Italy at Salerno in September 1943. But the SCR-300 was not the radio that German officers found in Sicily. That distinction belonged to an even more revolutionary device, the SCR-536. The idea came from watching a National Guard exercise in the late 1930s. Don Mitchell, chief engineer at manufacturing, observed how vehicle-mounted radios were abandoned. Mud and confusion when troops had to move on foot. Commanders lost contact with their men the moment they left their vehicles. Mitchell returned to Chicago, convinced that military communications had to follow man to the greatest degree possible. He began designing a radio that could be carried in one hand like a telephone. Concept was radical. No one had ever built a two-way radio small enough to hold like a telephone handset. Engineering challenges were immense. The device had to transmit and receive voice clearly over useful distances while running on batteries small enough to fit inside the handset. Every component had to be miniaturized beyond anything previously attempted in military equipment. Mitchell and his team solved problem after problem. They used 5 miniature vacuum tubes, each smaller than a thumb. These tubes were products of the American consumer electronics industry, developed for portable civilian radios and now repurposed for war. They designed a 40-in telescoping antenna that doubled as the power switch. Pull it out to turn the radio on, push it in to turn it off. Mechanism was simple enough that a soldier could operate it in complete darkness or while under fire. The entire unit weighed just 5, including batteries, and could transmit voice up to 1 mile over land, 3 m over. It operated on AM rather than FM, which limited its noise immunity, but the compact size and lightweight made it invaluable for situations where the larger SCR-300 was impractical. Signal Corps initially dismissed the SCR-536 as a stopgap radio because of its limited range, but paratroopers needed something lightweight enough to carry during combat jumps. Every pound mattered when you were floating down under a parachute into enemy territory. The little handheld radio found its mission. By July 1941, the SCR-536 was in mass production. Approximately 130,000 units were manufactured during the war by manufacturing and other firms, including Electrical Research Laboratories of Illinois. The SCR-536 first saw combat during Operation Torch in November 1942. Within months, it was in the hands of every American infantry company, and in Sicily it fell into German hands. German analysis of the captured equipment must have been sobering. Their own portable radios were larger, heavier, and less capable. The closest German equivalent to the SCR-300 was the Tourist D2. It operated on AM at 33.8 to 38 m with approximately 1 watt of power and roughly 3 of voice range. Unlike the one-man SCR-300, the German D2 was typically split between 2 soldiers for transport. One carried the transceiver. The other carried the battery and power supply connected by cable. If the 2 soldiers became separated in combat, the radio was useless. If the cable was severed by shrapnel, the radio was useless. The system was cumbersome, vulnerable, and far less mobile than its American counterpart. For company and platoon-level communication, Germany fielded the series. These were smaller single-soldier portable radios, but the United States Signal Corps obtained and analyzed them in detail. Their classified assessment, published in Tactical and Technical Trends No. 43 in January 1940, delivered a devastating comparison. The distance over which satisfactory operation may be expected from the German sets is theoretically about 1 for the distance over which the American sets can operate, 1 for the range. German radios could reach perhaps 500 m reliably. the American SDR-536 could reach a mile, the SCR-300 could reach 8 mi under good conditions. This was not a marginal difference, it was a fundamental asymmetry that shaped how the two armies could fight. Germany had no equivalent to the handheld SCR-536 at all. The E-spectrum confirmed that the Axis powers apparently never had the equivalent of the SCR-536. Germany's closest attempt, the D, was developed by Philips and entered service only in October 1944, more than 3 years after the American radio entered mass production. Even then, there was a two-piece system requiring separate radio unit and battery box with external headphones and a throat microphone. It was not a true one-piece handheld. Its production was repeatedly disrupted by Allied bombing of Philips facilities in the Netherlands, and surviving examples show visible decline in component quality as the war progressed and materials became scarce. The quartz crystal gap compounded German disadvantages. Every modern radio depends on quartz crystals to maintain precise frequency control. Without crystal control, radio frequencies drift as components warm up, making it difficult to maintain contact and impossible to operate in dense channel environments. The United States scaled crystal production from roughly 100,000 units per year in 1939 to approximately 30 million per year at peak wartime. Output total wartime production reached tens of millions of crystals, representing one of the largest scientific manufacturing undertakings of the war. American industry solved manufacturing problems that had seemed insurmountable, developing new cutting techniques and quality control procedures that output 100-fold. Germany, cut off from Brazilian quartz deposits by Allied naval blockade, produced only a fraction of what America manufactured. Göring's policies had emphasized domestic production of strategic materials, but Germany had no significant quartz deposits. This forced German radios to rely more heavily on free-running oscillators rather than crystal control, resulting in less stable frequency management and inability to operate in the dense channelized frequency environment that American FM radios navigated effortlessly. The tactical consequences of this communications gap were visible on every battlefield where American and German forces met. By Normandy, every rifle company of the United States, 29th Infantry Division, carried 6 SCR-536 radios, 1 for each of 3 rifle platoon, 2 for the weapons platoon, 1 for the company commander. At battalion to regiment level, SCR-300 backpack radios provided reliable FM voice links. American infantry could coordinate in real time at every level of command. A platoon leader under fire could speak directly to his company commander. A company commander could speak to battalion headquarters. Information flowed up and down the chain of command in seconds. Standard German organization placed radio only at company level and above. Platoon leaders communicated with their company headquarters by runners, wire, or visual signals. If a German platoon leader needed to report enemy movement, he sent a man running across open ground exposed to fire. If an American platoon leader needed to report enemy movement, he spoke into a handheld radio and the information reached his commander seconds without exposing anyone to additional danger. This difference was measured in lives. The American fire direction center system exploited this radio advantage to devastating effect. Forward observers, averaging roughly 21 years old, advanced with the infantry and transmitted target coordinates via FM radio to centralized fire direction centers behind the lines. These centers converted the data into firing solutions and could mass fire from multiple batteries onto a single target in minutes. A young lieutenant with a radio and a pair of binoculars could bring down the fires of an entire artillery battalion on enemy positions almost instantly. He could adjust fire in real time, walking shells onto targets that tried to move. He could shift fire from one objective to another without delay. This responsiveness was impossible without reliable radio communications. The FM radios were critical because noise immunity was essential. Forward observers often called in fire support while sheltering behind tanks, crouching in shell craters, or advancing under fire. Engine noise, explosions, and electrical interference surrounded them constantly. An AM radio would have been useless in such conditions. The static would have drowned out every transmission. The FM radios cut through the chaos and delivered clear voice communications regardless of battlefield conditions. General George observed that artillery won the war. He was describing this integrated radio artillery system. American artillery became the most feared element of United States combat power precisely because radio made it responsive and precise. German soldiers learned to dread the moment when American artillery began to fall. It came too fast, too accurately, and too heavily to escape. The German experience at Pass in February 1943 should have provided ample warning of American potential. Field Marshal RML's Africa Corps tore through inexperienced American positions, units broke and ran, equipment was abandoned. American casualties exceeded 6,000 men. The United States Second Corps lost 183 tanks, 104, 208 guns, and 512 trucks. Approximately 3,000 men were captured, many of them in the first chaotic days of the German breakthrough. But what happened next revealed something the Germans failed to appreciate. The Americans recovered with startling speed. Within weeks of the disaster, they reorganized their forces, relieved incompetent commanders, and implemented brutal lessons learned. General George took command of the demoralized Second Corps and transformed it through sheer force of will, imposed discipline with ruthless intensity. He demanded standards that seemed unreasonable to men who had just been routed, but he also listened to what had gone wrong and fixed the problems systematically. Tactics improved, coordination tightened, air support became more effective, communications procedures were revised based on actual combat experience. The American military possessed an institutional commitment to learning from failure that the Germans never fully understood. After the Army's Ground Forces commander conducted a comprehensive review of what had gone wrong, his findings were sent back to training camps across the United States where they shaped the preparation of divisions that had not yet deployed. The mistakes of February 1943 became the curriculum of March 1943. By May 1943, 3 months after the war in North Africa was over, 275,000 German and Italian soldiers marched into prisoner of war cages. More than had surrendered at Stalingrad. The Americans who had panicked were now among the victors. The fighting in Sicily that summer provided the first clear evidence that German forces recognized American radio superiority. SCR 536 units were captured and examined by German signals specialists. By some accounts, SCR 300 sets fell into German hands as well. The German signals establishment had to confront an uncomfortable reality. Enemy-possessed communications technology that Germany could not match and could not replicate. The evidence of German appreciation for American equipment became explicit during operation in December 1944. SS Otto, the famous commando who had rescued from captivity, attempted to equip Brigade 150 with captured American vehicles, weapons, and equipment for a deception operation during the Battle of the Bulge. His men would wear American uniforms and drive American vehicles to spread confusion behind Allied lines. Encountered an unexpected obstacle. German units that had captured American equipment found it better than German equipment and refused to surrender much of it. Combat soldiers who had used captured American radios, vehicles, and weapons knew from experience that the equipment was superior. They were not willing to give it up for a special operation, no matter how important. Obtained only a fraction of what he needed: 4 scout cars instead of armored vehicles, 30 jeeps instead of tanks, 15 trucks instead of the planned armored force. Operation achieved some tactical success in spreading confusion, but it never reached its ambitious objectives, partly because combat units would not relinquish their captured American gear. The most authoritative German assessment of American radio capabilities came after the war. In March 1950, General Trooper Albert wrote a 250-page report for the United States Army Historical Division titled German Radio Intelligence. Brown was the last Chief of Army and Armed Forces Signal Communications, appointed on November 1, 1944, after his predecessors and Fritz were executed for involvement in the July 20 plot against. Braun had survived the war and the purges. He had commanded German signals troops from the Eastern Front to the final collapse. He understood better than almost anyone what American radio superiority had meant on the battlefield. His report, originally classified confidential and later by the National Security Agency, dedicates Chapter 4, Section 3, specifically to appraising United States Army radio communications. The full document is available from the NSA's documents collection. Brown's structural choice devoting a formal appraisal section to American radio capabilities alongside evaluations of Soviet and British systems reflects the seriousness with which Germany's senior signals officer regarded American communications. Technology, this was not a minor factor in German defeat. It was significant enough to warrant formal analysis. Decades after the war ended, the industrial base that produced these radios had no Axis equivalent. Manufacturing corporation founded by and his brother Joseph in Chicago in 1928, he had started by making battery eliminators for home radios before creating the brand for car radios in 1930. The name combined motor and meaning sound in motion, reflecting the company's focus on mobile electronics. By 1936, returned from a tour of Europe, convinced that war was imminent and directed company research toward military applications. He saw what was happening in Germany and understood that America would eventually be drawn into the conflict. When war came, manufacturing was already prepared to produce military equipment. Competed against Gay and at the Fort Acceptance trials for the SCR 300 contract, they won on the strength of their FM design and their demonstrated capability to produce complex electronics at scale. During the war, the company produced nearly 50,000 SCR 300 units and was the primary manufacturer of the 130,000 SCR 536 units, but the effort extended far beyond one company. Mass-produced miniature and vacuum tubes. They built approximately 80% of all magnetrons for radar and produced tubes rugged enough to survive being fired from a cannon inside proximity fuses. RCA pioneered the miniature tube format that made handheld radios possible. Western Electric, the manufacturing arm of AT&T, supplied tubes and components on an enormous scale, developed ultra-low power filaments critical for battery-operated equipment. The Signal Corps engineering laboratories at Fort, New Jersey, employing about 14,000 personnel during the war, coordinated the entire development pipeline. The adjacent camp facility housed the Joint Army-Navy Tube Standardization Laboratory and served as the primary center for radar development. Fort's labs had been experimenting with FM transceivers since 1936, laying the groundwork for the rapid development that followed. America's civilian radio culture provided irreplaceable human capital. By 1939, approximately 51,000 Americans held amateur ham radio licenses. These hobbyists understood radio technology from practical experience. They had built their own equipment, they had troubleshot problems, they had developed intuitive understanding of radio propagation. When wartime amateur transmissions were suspended, these operators flowed directly into the military as radio technicians and signal officers. They brought practical expertise that no training program could replicate. Germany had nothing comparable. The Nazi regime had restricted amateur radio activity, viewing it as a potential security threat. German soldiers received formal training, but they lacked the hands-on experience that came from years of amateur operation. At D-Day, the Signal Corps faced an unprecedented challenge. The invasion of Normandy would require coordinating the largest amphibious assault in history across 5 beaches. Spanning 50 mi of coastline, thousands of aircraft would provide air support. Hundreds of naval vessels would bombard shore defenses. Tens of thousands of soldiers would land in the first wave. Alone, every element of this massive operation needed to communicate with every other element. The Signal Corps estimated it needed approximately 90,000 transmitters for Operation Overlord. Radio channels outnumbered available frequencies 7-to-1. The electromagnetic spectrum over the Normandy beaches would be more crowded than any battlefield in history. If radios interfered with each other, if frequencies drifted and overlapped, the entire operation could dissolve into chaos. The solution, narrowing guard bands between channels to as little as 4, was enabled by controlled FM precision. Without crystal control, transmitters would drift into adjacent channels and create interference. With crystal control, frequencies stayed exactly where they belonged, and thousands of radios could operate simultaneously without mutual interference. The 71 million quartz crystals that American industry had produced made this possible. German radios, lacking crystal control in sufficient quantity, could never have managed such dense channel allocation. It worked. In the first 3 weeks after the landings, only about 80 interference complaints were registered. Among all transmitters, This was a remarkable achievement in history's most crowded electromagnetic environment, and it went almost unnoticed because it simply worked. The Army pulled 100 FMCR 610 radios as insurance against enemy AM jamming during the assault phase. American planners understood that the Germans might try to jam their communications. FM provided inherent resistance to jamming that AM could not match. The beaches were chaos, men died in the surf, equipment was lost, units landed in the wrong places, but communications held. Commanders could speak to their subordinates. Forward observers could reach the fleet. Artillery ships could receive targeting data, the invisible web of radio links that connected all elements of the invasion force remained intact because American FM radios worked when AM radios would have failed. During the Battle of the Bulge, the SCR-300 became what one source called key equipment in preventing confusion during the German offensive. Bad flying weather and dense forest canopy grounded Allied air support for critical days. The fog and low clouds that hampered aircraft also disrupted visual signaling. Forward observers with radio links became the primary means of directing devastating American artillery fire against the German advance. Without those radios, the German breakthrough might have succeeded. That broke through American lines were stopped not by aircraft, but by artillery directed by observers using FM radios. In the Pacific, the SCR-300 proved essential in jungle terrain where line of sight was limited and wire communication was constantly severed by artillery, wildlife, and rot. Telephone wire strung through jungle was cut within hours by creatures ranging from rats to elephants. Radio was the only reliable means of communication in such conditions. After the disastrous performance of AM radios in November 1943, the Marine Corps discarded its AM equipment entirely and adopted Army FM sets. It was a decisive institutional endorsement of FM's superiority. The Marines had learned the hard way what happened when communications failed under fire. They were not willing to suffer those failures again. The men who designed these radios faced their own struggles. The Polish engineer who holds 3 patents on the SCR-300 worked knowing his homeland was under Nazi occupation and his family was in danger. He poured that knowledge into his work. Every circuit he designed, every problem he solved, brought the defeat of Nazi Germany closer. Whose FM technology made the possible faced a different kind of tragedy. After the war, RCA chose to prioritize television over FM radio. David, head of RCA and once close friend, blocked FM's commercial development. RCA successfully lobbied the FCC to shift the FM band from 42 to 50 M to 88 to 108 M, rendering approximately 400,000 existing FM receivers obsolete. RCA then claimed its own FM patent and used the technology without paying royalties, filed suit in 1948. Litigation consumed his fortune and health. On January 31, 1954, jumped to his death from his 13th floor apartment in Manhattan. His wife Marion eventually won over $10 million in settlements from 21 infringement suits, vindicating his legacy. But the inventor of the technology that helped win the war died broken by legal battles against a company that owed its radio business to his genius. Daniel Noble continued after the war, eventually becoming chairman of the board. Company he helped build became one of the giants of American electronics, developing technologies from pages to cell phones. Remained in America, unable to return to communist Poland after the Soviets replaced the Nazis. He continued working as an engineer until his retirement. His contribution to victory largely forgotten by the public, but remembered by those who understood radio technology. The radios themselves passed into history. The SCR-300 was eventually replaced by newer designs. The SCR-536 became a collector's item sought after by military antiques enthusiasts. A few still work, their tubes still glowing. After 80 years, they are artifacts of a moment when American innovation, American industry, and American determination combined to produce tools of war that their enemies could not match. The German experts who examined that captured radio in Sicily in 1943 were looking at more than a piece of equipment. They were looking at the evidence of an industrial and technological gap that Germany could never close. Their country had brilliant engineers and brave soldiers, but America had something Germany lacked. Electronics industry shaped by decades of consumer market competition, a culture of innovation driven by Commercial pressure, tens of thousands of amateur radio operators who understood the technology from practical experience, and an inventor named who gave his country a revolutionary technology and asked nothing in return. The gap that mattered most was not any single specification, but what radio density enabled at the tactical level. Consider what this meant in practical terms. A German company commander spots American tanks approaching his position. He needs artillery support. He sends a runner to battalion headquarters with the request. The runner takes 5 minutes to reach headquarters, assuming he survives the journey across open ground. Battalion staff assess the request and forward it to the artillery. Another 5 minutes. Artillery calculates firing solutions and begins to shoot. By the time shells begin falling, 15 or 20 minutes have passed. The American tanks are no longer where they were reported. The fire falls on empty ground. An American company commander spots German tanks approaching his position. He speaks into his SCR-300. The message reaches a forward observer within seconds. The forward observer radios the fire direction center. Within minutes, artillery shells are falling on the exact position of the German tanks because the forward observer can see them and adjust fire in real time. The German tanks are destroyed before they can close with the American position. This scenario repeated itself thousands of times across every theater of the war. The Americans could observe, report, and respond faster than the Germans because their communications technology enabled a speed of coordination that German equipment could not match. It was not that German soldiers were less brave or German officers less competent. They simply could not process information and respond to changing situations as quickly as Americans equipped with FM radios. The evidence is documented in primary sources that survive to this day. Albert Prahn's report is available from the National Security Agency. The Signal Corps assessments are preserved in military archives. The technical specifications of both American and German radios can be from original manuals. The story is not mythology. It is history recorded by participants and verifiable by anyone willing to examine the records. Nations still underestimate their adversaries. Leaders still confuse their assumptions with reality. The German High Command believed what it wanted to believe about American industry and technology. They saw what they expected to see rather than what actually existed. The cost of that misjudgment was measured in battlefields lost, campaigns failed, and ultimately in the total defeat of Nazi Germany. The factories that built the SCR-300 and SCR-536 are mostly gone now. The manufacturing plant on Augusta Boulevard in Chicago has long since been replaced. Fort was closed by the Base Realignment and Closure Commission in 2011. The engineers who designed these radios have passed away, died in 1978. Daniel Noble died in 1980. The soldiers who carried these radios into battle grow fewer each year, but the lessons remain. Wars are not won only by courage and determination. They are won by the quiet work of engineers and factory workers, by inventors who solve problems others thought impossible, by industries that can produce not just weapons, but the technologies that make weapons effective. Invented a technology that saved countless lives, and his own country's corporations drove him to suicide, fled one tyranny only to help defeat another, and then could not return to his homeland because a new tyranny had replaced the old. The history of technology is often a history of human tragedy alongside human achievement. A handheld radio that weighed 5, a backpack radio that cut through static. These were the tools that helped defeat Nazi Germany. They deserve to be remembered. If you found this story as compelling as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters, each one deserves to be remembered, and we would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans the globe, from veterans to history enthusiasts. You are part of something special here.